Welcome to a new VolLog. If you remember VolLog number 117, in that video we analyzed some eBay Bussmann fuses, in fact these ones right here, and we tried to figure out if they were fake or real Bussmann fuses. The eBay fuses were way cheaper than anywhere else, so that made me suspect they're not genuine. We didn't have any genuine units in the previous video to compare with, but this time, thanks to the help of velectron.com, which is a distributor of test equipment from Germany, we have some genuine Bussmann fuses that they kindly provided for this test. So I encourage you to check out their website. They have really good prices on these fuses. I will put a link in the description below. So they sent me a couple of DMM-B-44 100R and a couple of DMM-B11A. So these are the two fuses found in the Fluke 87 as well as many other professional multimeters. I believe the Bussmann uses them as well. They've also included this PCB ruler in the package. It's a nice PCB ruler. It's different from all the others that I have. So thank you VElectron for supporting this video. Let's open these envelopes and see how the genuine fuses look. Okay, so we got the R version this time. Let's set these aside. And these are the 11 amps fuses. Let me grab a marker and mark these because we don't want to mix these up with the ones from eBay. So I'll put a small G on these ones just so I know these are the genuine fuses. These are the fuses that I got from eBay. So this time I went for the DMM-B-44/100R. These should be identical in specs to the version without the R. It's these ones that we took a look at in the last video. But from what I could gather from the internet, they should be identical in terms of specifications. Maybe they have different independent laboratory testing or something like that, but in terms of their actual performance, they should be identical to the version without an R in their name. So let's take a closer look at the 440 milliamps fuse. We have the genuine fuse on the left, the eBay one on the right. They have identical writings on them with slight differences in quality. This looks like a date code on the eBay one Z46, and it looks like it's blacked out on the genuine fuse, but it says Z22. Almost identical colors, slight difference between the background, the violet color on the Bussmann logo, and I must say slightly worse quality on the printing on the genuine fuse. If we look closely, the text on the eBay fuse, which is on the right, is slightly sharper and looks like higher quality than on the genuine fuse. But other than that, I couldn't find any differences between the two. The end caps are the same. They have the same markings on the end caps, same font, same size, same style of crimping. Like the only difference I could find between these two is the genuine fuse has this blacked out region for the supposedly date code and slightly less sharp text on the label. But other than that, they look identical, and these types of differences that I'm noticing are not really relevant. They could be different between different manufacturing lines or batches, so I'm not sure that's relevant. Now let's also take a look at the 11 amp fuse. Looks like this time the supposedly date code is visible on both of them, but they are different. We have the genuine on the left, the eBay one on the right. Exactly the same writing except for the part number, which seems to have a slightly bigger font on the eBay fuse. But the colors are the same, the quality of the printing seems to be very similar. We also seem to have a different crimping style on the eBay fuse and slightly different physical dimensions on the eBay fuse. So in this case we do have some differences, because you see on the eBay fuse there is this crimping style, but on the genuine fuse it looks like it's just folded metal. It's good to know if these eBay fuses are real or not, because they are selling a lot of them on eBay, Amazon and AliExpress, and people might be relying on these to perform as required when in fact they might be out of spec. For the average bench user, which only occasionally goes up to 240 volts AC, it might not be an issue if the fuse is slightly outside the specs, but if you are probing some high energy circuit and relying on the eBay fuse to perform according to the datasheet and it is not, then something serious might happen, like the multimeter could explode because of a high energy discharge, or it could simply damage the meter, which I'm sure most of you would like to avoid. So now let's continue by taking some physical measurements, and I'll write these down in a table. The weight of the fuse might be a differentiating factor between the genuine ones and the fake ones. So let's start by measuring their weight. This is genuine fuse number 1, 6.55 grams. Genuine fuse number 2, 6.57 grams. eBay fuse number 1, 6.43 grams. eBay fuse number 2, 6.48 grams. Once again, the 11 amps genuine fuse number 1, 8.20. Genuine fuse number 2, 8.48. And eBay fuse number 1, 8.37. Next, we're going to continue by doing some physical measurements, because these are given in the datasheet of the fuse. Let me bring up the datasheet. So we have the physical dimensions for the 440 milliamps fuse. It should have 10.3 millimeters in diameter at the end cap and a length of 34.9 millimeters for the B44 and 38.1 millimeters for the B11A. So this is genuine fuse number 1, 10.38, 10.26. We have a variation between the two ends, 10.27. eBay fuse number 1, 10.35. Next, I'm going to continue with measuring the resistance of these fuses, because the resistance might vary. If the eBay ones, for example, if they're counterfeit, they might be using a different wire inside with a different resistance, so that could be a good indication. To do this measurement, I'm going to use a pair of Kelvin test leads. This will provide the best accuracy in this case, and I'm using my 6.5 digit Agilent 3441A. I must say I got these Kelvin leads recently, and they have a very good price. I got them for $17 shipped, and to my surprise, they feel like really good quality leads. They have these soft silicone leads, some nice big alligator clips with what looks like to be gold plating. So I will place a link in the description to these. I highly recommend them if you're into 4-wire measurements. I think you'll be happy with what you'll get for $17. So let's start by measuring the genuine fuse number 1. 0.676 ohm. Genuine fuse number 2, 0.695. eBay fuse number 1, 0.692. eBay fuse number 2, 0.709. Now for the 11 amps fuse, genuine fuse number 1, 8 milliohms. Genuine fuse number 2, 9 milliohms, and eBay fuse number 1. Wow, this one is really off. This one is 0.776. So it's like 100 times larger than the genuine fuses. This one really has a big difference when compared to the genuine fuse. Yeah, let's try to measure again one of the genuine fuses. So big difference here. The datasheet of the fuse gives us this figure of 6 degrees rise over ambient temperature when carrying 100% of the rated current. So in my next test, I'm going to measure the temperature of the fuse while passing 100% of the rated current, which is 440 milliamps, through the fuse. The Fluke is measuring the current, the MetraHeat E-Tech is measuring the voltage drop on the fuse, while this small meter right here is measuring the temperature on the body of the fuse through this thermocouple that I have attached to the body of the fuse. So let's start the test. We can see we have exactly 440 milliamps going through the fuse. We have 351 millivolts voltage drop on the fuse, and we should see the temperature rising slowly, but it should not exceed something like 6 degrees over the ambient temperature, which right now is 25 degrees. So I'm going to leave this running for a while and get back to you. Around 12 minutes have passed since we started this test, and it looks like we're around that figure of 6 degrees difference between the ambient temperature and the body of the fuse. It would probably go half a degree or 1 degree over, but that's not really relevant. If something was to be wrong here, it would have been way over the limit. And also I don't know on what type of text fixture they did the original test for the values given in the datasheet. They might have used a socket for the fuse soldered on a PCB, and that will help dissipate the heat from the body of the fuse while I'm testing it free air, just stuck on those alligator clips. So a few degrees up or down in this test is not really relevant. Let's move on to the other fuses. We are now doing the same test for the eBay number 1 fuse. There's no point of repeating this test on all of the fuses. I'm just going to test just one out of each batch. Let's start the test. So we're starting at almost the same temperature. T1 is the temperature on the body of the fuse. T2 is the ambient temperature measured by this second thermocouple. So same as with the previous fuse, I'll let this run for 10 minutes or so. "12 minutes have passed for the eBay fuse, and we got about the same result, slightly over 6 degrees. I think we're 1 degree over the spec number, so it's nothing too bad. I would call the two fuses, the genuine fuse and the eBay fuse, almost identical in this regard. Now we're going to continue by destroying these fuses. We're going to test them at 2 amps and see how long it takes for the fuse to break connection. So I'm going to refresh your memory. This is the test circuit. We have an LM338 in constant current mode, which is going to produce around 2 amps, actually 2.1. We have a relay in series with the circuit, so we can break the and make the connection as we wish. Here is the fuse under test that will be connected on these big alligator clips. Right here I have a 1 ohm resistor to which I am attaching the oscilloscope probe. This way we can visualize the current waveform on the scope, because we're measuring the voltage drop on this resistor, which will vary according to the current that passes through the resistor. And I have my fluke right here. We're going to use the fluke just to check the current, and then I'm going to remove the meter. So let's short these two together. So now if I trigger the relay, we should see around 2.1 amps on the fluke. Yep, and we're seeing the current. So right now there's no point of keeping this meter in the circuit. I'm going to remove it to simplify things. Just to verify that the system is working, I'm going to load this test glass fuse in my setup. This is a 0.3 amps fuse. So let's see what we can record on this small fuse. The scope is set to trigger on single capture. Let's trigger the relay. Okay, so we have our data on the oscilloscope. It looks like it took about 240 milliseconds for this fuse to blow. So now let's move on and test our first Bussmann fuse. This is genuine fuse number 1. Let's load it into the test jig. The scope is set to capture. Now let's push the button and hope everything is okay. Okay, so we got something on the scope. Let's take a closer look. It looks like the time is slightly over 40 milliseconds. And according to the data sheet, we were expecting between 30 and 40 milliseconds. It's also worth mentioning that we have this strange hump back here. Like the current only stayed at 2 amps for about 25 milliseconds, and then it dropped to half, to just about 1 amp for another 15 milliseconds. Let's load our genuine fuse number 2. And we got almost identical results, this time exactly 40 milliseconds with the same strange waveform. The current stays at 2 amps for about 25 to 30 milliseconds, then another 10 milliseconds at around 1 amp. Now let's load the eBay fuse number 1, which is this one, the the scope is set to capture. I'm ready for triggering. And the eBay fuse didn't trigger as expected. I didn't capture all the moment, but we can see we have here 6 divisions at 20 milliseconds. We have 120 milliseconds and the fuse did not trigger during this interval. Let me check if the fuse is still connected. No, we are seeing 40 something megohms, so the fuse did break. Let's try and see if it conducts anything at this point. Nothing. Yep, so the fuse really exceeded its rating in this case. We're talking about the eBay fuse. At least what I could record, we had 120 milliseconds recorded and the fuse was still conducting at that time. So for the next test, I'm going to expand the window on the scope and hopefully we're going to capture more information. So let's go on 100 milliseconds per division, single capture. Let's trigger. Okay, so this one behaved differently. You can see in the case of the second eBay fuse, we got about 37 milliseconds, which is right on that datasheet figure that we were expecting. So it's going to be hard to evaluate this with just 2 eBay fuse because one of them exceeded the rating by a lot and one of them was right on the datasheet figure. Unfortunately, I will not be able to electrically test the 11 amps fuses. I don't have any power supplies that can go over 10 amps and I need to have like at least 20 amps or maybe even 30 to test one of these fuses, so I'll not be able to electrically test these. The next phase is to open these fuses and analyze the internals. We can take a look at how they are constructed inside, what type of filling material they're using, what thickness does the tube have, and we can compare between the genuine and the eBay fuses. So let me pause the video for a second while I open the first fuse. I'm sorry I didn't have the camera turned on for recording. The first attempt at opening the fuse is a complete mess. As you can see, I have this powder all over the bench. So genuine fuse on the left, eBay fuse on the right. These how would I call these? Like this is the piece that would hold the wire inside all the powder. So these two pieces, to me, they look just identical, the same material, and inside they seem to be stuck with the same yellowish glue. So it's time to discuss the results we obtained, and I have put together this table. And to start with the physical measurements, I would consider all of them passing this test, and the results are also consistent with the previous batch of fuses that I tested in VolLog 117. I mean, the variations are so small that I would consider them as part of the manufacturing process tolerance. Next, for the internal resistance measurements, we don't have a datasheet value, but we can compare between units, and once again, the results were consistent with the previous batch tested in VolLog 117. With one exception, the eBay 11 amps fuse showed an internal resistance which was almost 90 times higher than the genuine fuse. This is an important parameter of the fuse, and such a deviation is not acceptable and cannot be considered manufacturing tolerance. this fuse is certainly going to perform different from a genuine fuse, so I would call this one a fake. Regarding the temperature rise, they all performed according to the datasheet with up to 6 degrees rise over the ambient temperature at the full rated current. Unfortunately, I couldn't test the 11 amp fuse because I don't have an 11 amp capable power supply, and the leads I use might as well get hot and at that current level. Next, I did the destructive test where I tested the 440 mA fuses at a current of 2.1 amps to see how long it takes for the fuse to break the circuit. We were expecting around 40 milliseconds taken from the datasheet graph, and we got values around that value except for one of the fuses which went over 120 milliseconds. I didn't have the scope window wide enough, so I couldn't capture all of the event, but it was on for at least 120 milliseconds. Now, this is an important parameter of the fuse, and such a deviation is not acceptable and cannot be considered manufacturing tolerance, so I would also call this one a fake. Unfortunately, I wasn't able to test the 11 amp fuses because for this experiment I would have needed currents in the range of 50 amps to blow that fuse in about 10 seconds. It would be difficult and expensive to create a constant current source of that level. And the last test performed was to analyze the inside of the fuse. We got slightly different results on the thickness of the tube, but since it was a bit bashed from me trying to open it, I can't consider those measurements as valid. Regarding the powder filling, by looking under magnification, we observed the powder contained identical particles. They were the same color, the same size, and the same shape between all of the fuses. So, to conclude this, it is my honest opinion that the eBay fuses are fakes, but really good ones. Like, you could get ones that perform identical to the genuine fuses, but you could also get ones that really go out of range on some of the parameters. You could certainly use the eBay ones if you think the genuine ones from a good source are too expensive, but just don't go probing around high energy circuits if you're not sure your fuse is genuine. This theory could be further verified if I had a larger batch, let's say 10 genuine fuses. That way we could see that in a batch of 10 genuine fuses they all perform within spec, while in a batch of 10 eBay fuses there are some that go way out of spec. Or it could also prove the contrary, that even in a batch of genuine fuses there are some that perform out of spec. So far the batches I've tested are still pretty small to be 100% sure on the conclusion. But I encourage you to check out velectron.com. They have good prices on the genuine fuses, so you don't have to risk with the eBay ones. The link to their website will be in the description below. I will also be placing links to the equipment I use to do these tests, so make sure to check out those as well if you're interested. I hope you enjoyed watching this video. Make sure to subscribe to the channel and don't forget to hit the like button, that always helps, and I will see you next time.